Good evening, buenas noches, and thank you for tuning in. On behalf of the University of Miami Department of Medicine and all of us at Books and Books, I welcome you to a virtual evening with Dr. David Fagenbaum to discuss Chasing My Cure, a doctor's race to turn hope into action, an incredible story that demonstrates the potency of hope and what can happen when the forces of determination, love, family, faith, and serendipity collide. Dr. David Fagenbaum is a graduate of Georgetown University, the University of Oxford, the University of Pennsylvania, and the Wharton School, an assistant professor of medicine at the University of Pennsylvania, and the associate director for the Orphan Disease Center. He is co-founder and executive director of the Castleman Disease Collaborative Network. Dr. Fagenbaum has been recognized with multiple awards, including the Forbes 30 Under 30 for healthcare and the Rare Champion of Hope Award for Science. He lives in Philadelphia with his wife, Caitlin, and their daughter, Amelia. To moderate tonight's conversation, we're joined by Dr. Mikkael A. Sekeres. Dr. Sekeres is professor of medicine and chief of the Division of Hematology at the Sylvester Comprehensive Cancer Center, University of Miami Miller School of Medicine. Dr. Sekeres is a member of the American Society of Hematology, where he has served on the executive committee, the American Society of Clinical Oncology, and the Southwest Oncology Group Leukemia Committee. He has written over 50 essays for the New York Times and is the author of 7 books, including When Blood Breaks Down, Life Lessons from Leukemia, published in 2020. Throughout this evening's broadcast, you're invited to ask questions by clicking the Ask a Question button at the bottom of the screen, and we'll get to these at the end of the program. Dr. Fagenbaum will present first, then Dr. Sekeres will join him on screen for a conversation, and then we'll have time for a Q&A with the audience. I'll take a moment to remind you that you can order your copy of Chasing My Cure from Books and Books below by pressing the green button. We appreciate each and every order and the generous donations from viewers everywhere. And now, without further ado, I'd like to welcome our guest to the stage. Hello.
Hi, Christina. Thank you so much for that wonderful introduction. And thank you all for joining me virtually. I wish so badly I could be with all of you down in Miami, but I'm just thrilled to be with you virtually here from Philadelphia. When I was first asked to spend some time with you all, I thought I would put together a set of slides with pictures of my journey chasing my cure. When you hear my journey going from being this sick medical student to now being on the other side of things where I'm alive thanks to a drug that I identified, I think it's really important and helpful to show pictures along the way. So I'm going to begin by sharing my screen, which you all should be able to see. And just as was shared earlier, the name of my book, Chasing My Cure, I think really wraps up my journey into 3 words. Today, I'll be sharing a bit about my journey from being a healthy third-year medical student when I was training to become an oncologist in memory of my mom. This is a picture of my mom and I shortly after she was diagnosed with brain cancer and unfortunately passed away just a year after her diagnosis. But before she passed away, I made a commitment to her and promised her that I would dedicate my life towards searching for treatments for patients just like her. As I mentioned, I was a medical student at Penn, well on my way to become a doctor and take care of patients in her memory, when out of nowhere, I became critically ill with a disease called idiopathic multicentric Castleman disease. I spent months and months hospitalized. I even had my last rites read to me, and eventually relapsed on the only drug in development and realized the only way that I would survive is if I got involved in research and I began to search for a treatment that could maybe save my life. In the process of searching for treatment, I realized that I couldn't do it on my own. There was no way that I would be able to find a drug that could save my life without building a team. And so this picture on the far right of the screen is me with a number of other Castleman's patients, and I assembled an army to look for treatments for Castleman disease. So throughout my 15 to 20 minutes or so that I'll be sharing with you tonight, I thought I would just zoom in on a few moments in my journey that, of course, I had the opportunity to share a lot more about through Chasing My Cure, but that I thought you all may be interested. So I mentioned that I was this healthy med student, and all of a sudden I became critically ill. My liver, my kidneys, my bone marrow, my heart, my lungs all began to shut down for an unknown cause. I mentioned I had my last rites read to me because the doctors were certain that I wasn't going to survive. I gained 70 pounds of fluid. I needed dialysis and transfusions just to keep me alive. In the midst of this journey, with no diagnosis, by the way, a friend of our family actually gave my dad a phone number for a doctor at the NIH. And we were just totally out of options. I was pretty incapacitated at the moment, or at the time, but my dad started reaching out to this NIH doctor, and every day for about 3 weeks, my dad spoke on the phone with this doctor and shared my lab tests and what was going on, with the hope that a diagnosis could be made and maybe this doctor would have some answers. And about 6 months later, I eventually was discharged from the hospital, and I asked my dad, I said, "Dad, who is this doctor that you were calling every day leading up to my diagnosis?" And he said, "Oh, I don't know. I got his name from a friend. I think his name's Fucci. You should Google him." And so I Googled Fucci NIH, and I learned that this doctor that my dad was calling every day was Dr. Tony Fauci. And of course, everyone knows who Dr. Fauci is for his work with the COVID pandemic. But my dad and many of us certainly should have known who he was way back in 2010. He had already won a Presidential Medal of Freedom for the work he had done for HIV. So I shared this story because I think it's an important anecdote to highlight just how far our loved ones will go to help us when we're in the midst of tough times. My dad would have hounded an NIH director. He would have run across the country if it would have meant finding solutions for me during my most difficult times. Thankfully, the diagnosis was eventually made right around the time that priest read my last rites to me. Within about 48 hours, a procedure was performed to cut out a portion of my lymph node, and the diagnosis came back as this rare disease, idiopathic multicentric Castleman disease. And given that there were so few options, I was started on chemotherapy. And thankfully, chemotherapy really put my disease into remission. You can see here that I'm sitting up with my dad. My dad's got his hand on my belly. And I'm just so thankful to be alive. The challenges with idiopathic multicentric Castleman disease, it's a rare disease. So very little was known. And there were very few treatment options. There were no FDA-approved drugs. There was one drug in development, but at the time I didn't qualify for that trial. Unfortunately, about a third of patients with my form of Castleman disease will die within 5 years of diagnosis, and another third will die within 10 years of diagnosis. So it was a frightening diagnosis to receive, but thankfully chemotherapy saved my life. And you can see here, despite the fact that I just received this terrible diagnosis, I'm sitting up with my dad, and I'm just so thankful to be alive. You can see that my head's bald from the chemo. You can see my dad has his hand on my belly because it's just so big from my liver and kidney failure. And then this is a picture from just a few weeks later, and it's my dad and I standing up. I'm doing well. We're actually getting ready to walk a lap around the hematology oncology unit at the hospital I was at. And this was actually taken on New Year's Eve 2010. And as we passed the family waiting room, just a few minutes after this picture was taken, we saw that there was a gentleman who was clearly visibly drunk. He was kind of like swaying in his chair on New Year's Eve that evening. And on our next lap around, we saw that he had fallen onto the ground. And so my dad ran over to him and helped him back into his chair. And he looked at my dad and I, and he said, "Thanks so much. Good luck to you and your wife." I said, "Wife? What is he talking about?" And then I looked down at my belly and I realized that he thought that I was my dad's pregnant wife, which was a low point emotionally for both of us. But I turned to my dad, I said, "Man, Dad, you've got an ugly wife." And we managed to laugh so hard. So again, the lesson I highlight here, again involving my dad, is just that in the midst of really, really tough times, laughing with the people you love is so powerful and can be so helpful during the toughest of times. A third lesson I wanted to highlight from this time was that as I started to get better, and from this photo you can tell I'm starting to feel better, I reflected back a lot on what had happened over these 6 months, and I had nearly died 3 times in that 6-month period. And what I realized was that each time I nearly died, I reflected back on my life. And all 3 times that I reflected on my life, I didn't regret a single thing that I had done. The only things I regretted were things that I had thought of doing but never did. And so as I left the hospital and as I started to feel better, I made a commitment to myself. I said, if I think about doing something that's the right thing, I'm not just going to say, oh, I'll deal with that in the future, or oh, maybe I'll do that later. If I think it, I'll do it. And this became a motto that I live with, and something that was really, really important for me as I went on my journey chasing my cure. And here's a photo from me when I was discharged from the hospital, and you can maybe see how someone would have thought that I was a pregnant woman, or my father's pregnant wife, from the big belly from my liver and kidney failure. And then this is a picture from just a few years before. I played college football at Georgetown. I was a quarterback there. And I always say this is like the worst set of before and after pictures of all time. But if we could flip the order, it could be like this great advertisement for Peloton or for Muscle Milk or something like that. But unfortunately, the pictures are in the wrong order. I did take a picture every week for the next 8 weeks, and you can see my hair starting to grow back and my belly starting to shrink away. So I mentioned that a major lesson from my journey was around this idea of only regretting the things that I hadn't done, and living a life where if I thought about doing it, I would just do it. And one of the main things that I regretted was that I dated a girl named Caitlin for several years before I got sick, and we had broken up just a few months before I became ill. And we were 25 years old, and we had this feeling that if it's meant to be, it's meant to be. No need to worry about the relationship right now. Let's see what happens. And then there I was in the ICU having my last rites read to me, realizing I didn't have all the time in the world. And so when I got out of the hospital, the first thing I did was reach out to Caitlin and explain how much I regretted that I didn't fight for our relationship. And thankfully, she felt the same way. So we started dating again shortly thereafter. And this is us at our first Halloween. After starting to date again. I'm dressed as Borat. I hope everyone watching this knows who Borat is. And if you didn't watch the first Borat, I hope you watched the second Borat. I'm a super fan. And then this is another one of my favorite pictures. The picture on the right of the screen is from just a few months later. When I was discharged from the hospital, I was started on an experimental drug called Citizenshiп. It blocks a certain part of the immune system that we all hoped would be really effective in treating Castleman disease. And thankfully, it is effective for a large portion of patients. And I was getting this drug every 3 weeks. And during one of my infusions, the nurse actually asked if I wanted to leave the infusion suite and actually take the drug in a pump and have the drug continue to be pumped into my body while Caitlin and I went for a walk. And so you can see Caitlin and I going for a walk. And I think I love this picture so much because I think it's so symbolic. On one shoulder, I've got this experimental drug that I'm hopeful is going to keep me alive, keep me in remission. And on my other shoulder, I have Caitlin supporting me during such a difficult time. And I think this is just such a good symbol for what my life's been like for the last 10 years. Medical technology, but also love and support from family. Unfortunately, a few months later, despite this experimental drug, I relapsed and nearly died for the 4th time. This is a picture you can see. My head's bald now because of the multi-agent chemotherapy. And you can probably also appreciate in the picture that I'm pretty focused and I'm pretty concerned. And that's because just a few weeks before, when I was in the hospital, and I spent about a month hospitalized for this relapse, I learned from my doctor that there were no more drugs in development and that there were no more promising leads. He explained to me that I was out of options. And I remember being so devastated. And just shortly after he walked out of the room, turning to my dad and my sisters and to Caitlin and committing to them, promising them that I would dedicate the rest of my life, however long that may be, to trying to find a treatment that could help me and other patients just like me. And as soon as I got out of the hospital, which was a few weeks later, I was just on a mission, with the goal being to identify treatments that could be used to save my life and patients just like me. So the first thing I did was to begin to conduct laboratory research at Penn. There were no Castleman's researchers at Penn, but a researcher in the pulmonology department provided me some space in her lab, and I set up a protocol so I could start doing research on my own samples. And in parallel, I realized, as I said earlier, I couldn't do this alone. So I started a foundation called the Castleman Disease Collaborative Network with the goal of bringing together physicians, researchers, and patients to accelerate research for Castleman disease. And finally, I got involved in Penn's Orphan Disease Center. Penn had just been given a large donation to start up a rare disease center, and I got involved in it, hoping that I could learn from other rare diseases for Castleman's and apply what we're learning for Castleman's to other rare diseases. And I mentioned that shift that occurred, the conversation I had with my doctor where he told me that I was out of options. And there was a really important mental shift that happened. And that was, I went from being a really hopeful person who was optimistic and hopeful that solutions would happen, that treatments would emerge, to being hopeful still, but realizing that if I was going to hope for a treatment or a solution for me or someone I love, that I would need to take action to get closer to that which I'm hoping for. And so this is a quote from my book that I wanted to highlight. Hope cannot be a passive concept. It's a choice and a force. Hoping for something takes more than casting out a wish to the universe and waiting for it to occur. Hope should inspire action. And when it does inspire action in medicine and science, that hope can become a reality beyond your wildest dreams. The subtitle of my book is A Doctor's Race to Turn Hope into Action. And I think that's such an important theme of this book. And that's that we need to reflect on what we're hoping for, we're praying for, we're wishing for, and then ask, what can I do today to get closer to that which I'm hoping for? In the course of our work for Castleman disease through the Castleman Disease Collaborative Network and the research that I was doing, I ended up graduating from medical school and deciding to enroll in business school right afterwards because I felt that business principles and managerial aspects of research were really where the greatest need was. And so I decided to enroll in business school, but unfortunately, shortly after enrolling in business school, I relapsed and nearly died for the 5th time. The one difference between this relapse and all the previous ones was that this time I had a protocol in place to get blood samples on myself. I had a protocol in place to get lymph node tissue and bone marrow. And so as I got more and more and more sick, as I was hospitalized, a number of procedures were performed on me. And with each of those procedures and with every blood draw, we would collect separate samples and put them into our biobank, put them in the freezer. Because I knew that if I survived, I couldn't continue this in the hospital, out of the hospital, organs shutting down, going back to medical school, back in the hospital. I knew that I needed to find a drug that could maybe prevent my disease from relapsing, prevent my immune system from getting out of control and attacking my vital organs. And so now I was armed with data. And with that data, I performed a series of experiments to try to identify, is there something about my immune system that maybe we could target with a drug, something wrong with my immune system that maybe we could turn around with an existing drug. I knew that I didn't have the time or resources to develop a new drug from scratch, but if I could understand what was happening in my immune system, what was wrong with it, then I could ask what drugs are already FDA approved that can maybe fix the problem. And so over the course of weeks and weeks of experimentation and research, I identified that one part of my immune system called the Mtor Pathway seemed to be highly activated in my tissue, based on proteomic data, based on some experiments we did, flow cytometry, and also with cytokine panels. And then I wanted to confirm what I thought I was seeing, and that was to do a final experiment where I looked in my lymph node tissue to see, is this particular part of my immune system, is this communication line turned on? And I did a final experiment that suggested that yes, this part of my immune system was on, it is on. And thankfully, there's a drug that's been around for 30 years that's FDA approved for kidney transplantation and no one had ever used before for Castleman disease that's really good at inhibiting this one part of the immune system. And so I talked to my doctor about it, and we decided that given that there were no other options, and given that I had a wedding date about 5 months away that I wanted to make it to, May 24th, 2014, that we should start this drug. We should try it out. Let's see if sirolimus could work for me, this mTOR inhibitor. And today marks 86.58 months since I started on this treatment and that I've been in remission. I say 86.58 months because I know that I can't round up. I don't know if I'm going to be in remission for 87 months. I don't know if this drug is going to keep me feeling well for the rest of this month, but I also refuse to round down. I'm so thankful for every fraction of a month, a week, a day that I've received of remission and that other patients like me have been able to benefit from. So just so thankful for this remission. And of course, during this remission, I've been able to experience a number of things that obviously I never even dreamed I would be able to. So the New York Times called this "Doctor Cure Thyself," which I think is a bit of an overstatement. I think it should be doctor helping himself a little bit right now and hopefully for a lot longer. But I don't think that would have fit as a headline. Importantly, during this remission, Caitlin and I made it to our wedding day. We made it to May 24th, 2014. You can see my hair grew back just in time. That's never before been cut hair that you're seeing in this picture. And then importantly, just a couple years ago, we welcomed our daughter Amelia into the world. This is a picture of Amelia, Caitlin, and I at Halloween this year. You can see Amelia is dressed as Amelia Earhart, and Caitlin and I are her aviation crew, which I think is actually a very good analogy for how things are in our house. Amelia, she's the pilot, and we're just kind of trying to direct her and keep her going in the right direction. During this remission, I also was able to join the faculty at Penn, where I started the Center for Cytokine Storm Treatment and Laboratory, which up until about a year ago was primarily focused on Castleman disease and also the cytokine storm that happens in cellular immunotherapy. But given the emergence of the COVID pandemic about a year ago and the role that what's called a cytokine storm clearly plays in a small fraction of the most severe COVID patients, we've expanded our center to focus quite a bit on COVID-19. And you can learn about our work at cdcn.org/corona, learn about the Corona Project. So I just have two last photos to share before I'm really excited to open it up for some Q&A. This is a picture trying to highlight what I think is a really important takeaway from my journey. So I'm alive today because of a drug that's been around for 30 years and that no one had ever thought to try. And so the thing that keeps me up at night is the question, how many drugs are already FDA approved for something that could be treatments or cures for something else? We just don't know about it yet. And so what I'm trying to show here is that there are about 2,500 drugs that are approved by the FDA. And those 2,500 drugs are approved for about 3,000 or so different diseases. But there are about 7,000 additional diseases that don't have any approved drugs. So the big question is, how many of these 2,500 drugs could actually be used for some of the diseases that don't have any solutions? How many drugs like sirolimus are just hiding in plain sight? And I hope we'll do everything we can to find those. So I just want to close. This is my last slide by highlighting maybe the last lesson I'll have time to go through today. And obviously there's a lot more in the book from my journey, and in particular lessons I learned about living from nearly dying 5 times and eventually searching for and chasing my cure. But the last one that I would highlight tonight is that my book is called Chasing My Cure, but it really should have been called Chasing Our Cures, because there is just no way in the world that we would have made even 1/1000th of a percentage of the progress if it truly was me on my own, if I didn't have the support from my dad, my sisters, from Caitlin, if I didn't have an incredible team of physicians and researchers in Little Rock and Philadelphia and New York City, all over the place, that have been supporting the scientific exploration that we've been on and have been a part of helping to move this forward. So that's my one regret, is it should have been called Chasing Our Cures, because it really has been a team effort. And these are just some of the many people that have been part of this effort. You can see we're doing what we call the Castleman Flex. So Castleman disease is named after Benjamin Castleman, but we've kind of repurposed it to be a Castleman and a Castleman warrior at that. So thank you all so much for being a part of this tonight. I'm really thrilled to have the opportunity to share some of the lessons I learned from my journey with all of you, and eager to answer any and all questions that you might have.
Thank you, David. That was really inspiring. And I also want to thank Books and Books for sponsoring this. This is part of the University of Miami Department of Medicine Research Day, which aims to bring distinguished investigators like yourself to discuss your work and inspire our students, trainees, and faculty. I wanted to ask you a really basic question, at least this may seem basic to you. What does it feel like to have Castlemans, and what is Castlemans? How would you describe it to me as a doctor? What does it feel like? What do you go through? And then how would you describe it to some of our audience who are comprised of people interested in your book, doctors, medical students, other people in science?
Yeah, great questions. And I'm so happy to be able to share the screen with you this evening. So the way I would describe it is Castleman disease, and the type that I have, idiopathic multicenter Castleman disease, is really like a flu-like illness where you feel under the weather, you feel more tired than maybe you've ever felt. You notice lumps and bumps in your neck because you've got enlarged lymph nodes. And then unfortunately, importantly, your organs start to shut down. So your liver, your kidneys, your bone marrow, your heart, your lungs, these vital organs begin to shut down as a result of your immune system being out of control. And so I made a reference to COVID, and I think all of us are very well aware of what happens in the most severe COVID patients. We've seen pictures of them in the ICU on ventilators. Their organs are shutting down because their immune system is fighting so hard to kill this virus. And in the course of trying to fight off this virus, the immune system actually causes a lot of collateral damage. It's actually, the immune system is trying so hard to kill the virus. In doing so, it actually causes a lot of damage to vital organs. Well, in my form of Castleman disease, we have almost the same exact thing where my immune system is damaging all of my organs. The only difference is that we haven't identified a virus to explain why is the immune system out of control. But when I'm in the ICU, and if you look at my blood, it looks very similar to the blood of a COVID patient who's really sick in the ICU as well.
It's fascinating, and you tell the tale really well in your book. One of the hats that I wear, and we all wear a lot of hats when I think we're affiliated with the university, is as part of the editorial staff of a medical journal that accepts submissions from people in healthcare about, in my case, about people who have cancer. And one of the more familiar tropes that people in healthcare use is, I became a patient and then I learned what it was like to be a patient, and that made me a better doctor. But you actually came about it from the opposite direction. And I was going to read, so surprise, surprise, I'm going to read a portion of your book that really stuck with me.
Sure.
And I want you to reflect on it. Okay?
Yeah, I love that.
Okay. As I researched Castleman disease, I felt a part of me reemerging, a part I had had to lay down when I first dragged myself into the ER. I felt like a doctor again. Some of that identity no longer wore as well as it once did. As a doctor, I had been trained to look at disease as the sum of the parts that fit into our diagnostic tools. We were trained, rightly, to attend to what we could fix and what we could fix only. When I became a patient, the deficiencies of this straightened approach revealed themselves to me. I began to understand what Susan Sontag meant when she said that each of us is born with dual citizenship, ultimately obliged to spend some time in the kingdom of the sick. My disease wasn't just the sum of its symptoms. It became a relationship I had to the world and to the people around me. Do you want to reflect on that a little bit? It was a neat passage. And I love the Susan Sontag's work also.
Oh, thank you. Yes, I touched on a lot of things in that passage. Maybe I'll reflect on a few different aspects of it. So the first was that shift, an almost dizzying shift between being a medical student and then a patient. And while I was a patient, no one could figure out what was going on. So I was trying to kind of be that medical student investigator while I was simultaneously experiencing organ failure. And that was so difficult, this kind of going back and forth between fully being the patient, trying to be helpful as in the course of figuring out what was going on. And that particular portion of the book, I was starting to improve. And so my brain was working a little bit better. I was a little bit clearer on what was happening. And that felt so good. It felt so good to feel like I was contributing in a meaningful way. And so that's kind of the first part of it. The second part of it is this whole idea about dual citizenship of both being, those of us that are doctors, yes, we take care of the sick, but all of us that are doctors will at some point be sick. At some point we will be sick, and oftentimes someone we love will be sick. And so you talk about, being a doctor and then becoming sick, or in my case, being sick, becoming a doctor. I think it's so helpful and so important for us to remember the different perspectives. And so for me, I think one of the biggest eye-opening aspects of my journey was actually the engagement with the number of healthcare professionals that are not doctors in the healthcare system, and the incredible care that I received from my nurses, from the nursing assistants, from everyone in the system that I have to admit I didn't fully appreciate until I became the patient. And I wish that wasn't true, but it really took being a patient to appreciate, the complex nature and how many people are a part of this.
There's, healthcare is so complex, and a dirty little secret about being in the hospital is that a doctor will be in your room for probably no more than 15 minutes, unless that doctor is discussing something that's incredibly momentous, like starting chemotherapy for cancer or you're about to die.
Yep.
And the people who are spending 23 3/4 hours in your room are the nurses, the environmental services workers, the LPNs, this whole cast of incredibly important and precious characters.
You're totally right. And when you're in medical school, you're only in the room when you're in the room, right? So you don't know who else is in the room when you're not in the room. And so, yeah, I totally agree with you. Those numbers are right. I mean, sometimes it's even more like 1 to 5 minutes, a day with your doctor. But I totally agree with you.
So tell me a little bit about, how do you start doing research in a rare disease where there are only a handful of people in the world who have any interest in it whatsoever, and what some of the obstacles are to studying rare diseases?
Yeah, so there are unfortunately a lot of obstacles to studying rare diseases. When a disease is rare, so by definition, there are going to be fewer patients, there are going to be fewer samples, less data, less funding. These all kind of go with the fact that it's rare. And so it's challenging, and oftentimes it's disorganized, the research communities, because there isn't a large advocacy organization, to help to move things forward. And so for me, I felt that the ways that I could get started, first off, I would want to find out who were those people that were physicians and researchers that did care about it. As you said, that small core group of people, how could I connect with them? And then start looking at the next level, which is maybe it's not the people who think about it a lot, but maybe the people who think about it a little bit. Treat a few patients, do some tangential research. And so I started a community called the Castleman Disease Collaborative Network. We held a meeting at ASH back in 2012, and we would start holding these annual meetings, but in between meetings, we had a virtual community so they could connect with one another, share ideas about research, and then we started connecting in patients. So the idea was, let's first build a community. Let's get anyone and everyone, physicians, researchers, and patients connected. And then once we connected them, then let's start thinking through what are the most important things we can do with them. So with physicians and researchers, let's get the best ideas in the world for what research should be done. Let's work with patients to get samples and data collected. Let's raise some money early on to do some early research. And for us, it was a lot of little tiny steps, but all of a sudden we could launch our first study, learn things from that first study, and then those really, really snowballed from there.
So you mentioned that your first meeting was at the American Society of Hematology annual meeting, ASH, which we all just say ASH like it's nothing.
I know.
You mentioned your daughter. When I had a son who was about a little older than that, I remember reading him a book about baseball, and it said, this is a baseball, it's covered with leather. This is a base, it's in dirt. And it said, this is a bat, it's made from ash, from a wood called ash. And my son looked at me and said, ash isn't a wood, it's a meeting.
Yes, that's about how I feel right now.
That's about how big ASH is. So ASH is a meeting of 30,000 people every year. In that first meeting, 30,000 people, how many were you able to get together to talk about Castleman?
I got 27, and it was like the greatest feat of my life. I was so excited. I couldn't sleep the night before. I didn't sleep the night before. I was so excited to get these 27 doctors together to talk about Castleman's.
So 27 people in the worldwide society dedicated to hematology, 27 people.
That's right.
I want to put that in context a little bit. When people hear about a rare disease, you defined it in your book, and it's technically defined as a disease that affects fewer than 200,000 people, right? 200,000 people is a lot of people compared to how many have Castleman's. How many people in the world each year? What's the incidence and prevalence? So in other words, how many people have a new diagnosis of Castleman's and how many people are living with Castleman's?
So I have estimates for you, but in part, one of the challenges is that up until a few years ago, there wasn't a very good coding or classification system. There was no diagnostic criteria. There was no good coding system. And so the best estimates we have right now are about 5,000 new diagnoses per year in the US of all of Castleman disease. And my subtype, which is the most deadly, idiopathic multicentric, occurring in about 1,500 patients per year in the US. So you're right. So it's a rare and a small number.
So with a number of diagnoses that's that small, so can you talk a little bit about how do you do a clinical trial that's going to lead to a drug getting approved by the FDA? Because ordinarily the gold standard for clinical trial to get a drug approved at the FDA is a randomized study. Half the patients get a study drug, half get standard or placebo. And then hopefully you're demonstrating some improvement in overall survival or periods of relapse-free life. But you can't get that many patients onto a study. So how do you do it?
You're right. It's a good question. So there's one randomized controlled trial that's ever been done, a drug called siltuximab, where they enrolled 79 patients. And they showed, interestingly, none of the patients in the placebo group benefited from placebo, maybe not too surprising. And about 1/3 of patients in the treatment group benefited, and that was a statistically significant result. And so this drug, siltuximab, got FDA approval, got EMA approval. It's approved around the world for Castleman disease based on a trial of just 79 patients, which, as you know, is quite small. One comment I would make about siltuximab, and this is a story that I share in the book, is that the reason that this drug siltuximab was developed in Castleman disease and studied in Castleman disease is because there was another drug called tocilizumab that was developed decades ago also for Castleman disease. So siltuximab blocks a protein called interleukin-6. Tocilizumab blocks the receptor for that particular immune protein, the receptor, IL-6 receptor. And I knew that a colleague of ours, Kazuo Yoshizaki, who's on the scientific advisory board for the CDCN, I knew that he had discovered that this particular protein, interleukin-6, was elevated in Castleman disease. And I knew that he had developed the drug, tocilizumab, to try to block it. What I didn't learn until recently was I heard a rumor that Kazu had tested the drug on himself as the first human to prove that it was safe. And when I went to Kazu, I said, Kazu, Makoto just told me that you gave tocilizumab to yourself to prove that it was safe. And he said, no, I didn't give it to myself. The nurse, she gave it to me. So Kazuo Yoshizaki, he discovered interleukin-6 was important for Castleman disease. He made the drug to target it. He gave it to himself to prove that it was a safe thing for humans. He didn't die. And so then he went on to give it to Castleman's patients. It got approval in Japan for Castleman disease. And then kind of a next generation of that drug is siltuximab, the drug that's now approved here in the US. And I just love that story about Kazu, A, because I love Kazu and he's such an incredible physician scientist, although I don't recommend that approach. But I think B, it highlights this drug tocilizumab, as you know, is now being used in COVID. It's used in CAR therapy when patients experience CRS. This is an important example of how drugs developed for a rare disease like Castleman disease can then go on to have an outsized impact for other conditions.
So what advice would you have for patients with a new diagnosis of a rare or serious disease? How do they get started? I mean, initially you must be overwhelmed.
Totally.
You've heard of it before. What do you do next?
So number one is you go to Google and you find out who is the doctor that has the most experience. And if she is 20 hours away by car, you get in your car and you drive 20 hours to go see that doctor. I cannot emphasize enough that if you have a rare disease, you'll oftentimes be referred to someone in your town or your city that has some experience. But I personally don't believe that some experience is enough experience when it's a rare disease. I think that it's always great to have someone local who who knows you and follows you. But get in your car and just start driving to that person. I think you got to see the expert. The second thing is when you Google to find out who the expert is, Google to find out what organizations exist for your rare disease. Thankfully, there are a lot of rare diseases with rare disease organizations that help to coordinate the community, identify experts, sometimes do research, raise money for research. And if you can connect with that community and understand what are the greatest needs for Castleman disease, our greatest needs are samples from patients and data from patients. We need them to enroll into our registry. And so if you got Castleman disease, those are the two things we really need you to do. For other diseases, it may be we need your money for our research study that's necessary. And so I think it's about getting to the right doctor, connecting with the community, and trying to figure out what can you do today. I mean, like we said, the subtitle of my book, A Doctor's Race to Turn Hope into Action. All of us are hoping for treatments. What can we do to get closer to that?
That's great. One further thing I would add is sometimes patient organizations can help with those transportation costs.
Yes.
And can hook you up with clinical trials in an area that's not that far from you. It's incredibly crucial.
So maybe flip the order. Maybe it's find out the organization first and see if they can help you, then get to the expert. That's probably better order instead of just getting in your car and driving through the night.
Well, listen, David, I want to thank you so much. I think my time on the screen is up, and I believe it's time to open this up for questions from everyone who's tuned in.
Oh, that sounds great. Thanks so much for being a part of this. It's a real honor for me.
So Dr. Sekeres, you can stay if you'd like. There might be something here for you, but let me know. So David would like to know, obviously, you were lucky to be a physician and have a father who is a doctor. What barriers need to change for others in a similar situation to be able to do their own N of 1 experiment?
Yeah, this is a great question. So one of the things that I'm working on a lot right now, which I didn't get a chance to mention, is this concept of drug repurposing, which is the idea that there are drugs approved for a lot of things and we need to figure out all the ways they could be used. And then I did mention the problem, but what I didn't share about is a solution that we're working on. And that's something called the Cure Drug Repurposing Collaboratory. And the whole goal of it is to make it so that you don't have to be a med student that happens to be diagnosed with a disease to figure out that sirolimus could work for Castleman disease. The whole goal of this collaboratory is to make it so that there are systems in place so the drugs like sirolimus, that we actually figure out that they're helpful for Castleman disease without needing, all of the things to line up in my case. So the first thing is we have to create systems so that we can identify and the incentives are in place so that all drugs approved for one thing are determined and clearly found to be effective for all the other things that they could be useful for. So that's step one, which we have to do. Step two is, as a patient, if that hasn't been done yet, the first thing is to find that expert, to see where they are and to encourage that expert to involve you in the process, to let you know what drugs are out there, to let you know what maybe promising leads there may be out there. But it's hard to dive into the literature. But if you can have a partner in your doctor, a partner who's really fighting alongside you, I think that's so important.
So Kimberly says, as someone who has multiple rare conditions but is not a doctor, I wonder if your research would have been taken seriously by treating doctors if you had not been an MD as well. Does your organization encourage physicians to work as a team with their patients and their families when there are more questions than answers?
I think you're totally right. I think that even as a physician in training, I still had a lot of doctors saying, like, what are you doing, David? What are you talking about? Like, I've got this. Stay in your lane was kind of the feeling I got. So I can only imagine if I wasn't in the middle of my training, how I would have felt if I was doing research and encouraging, thought in new ways and without that sort of training. So I can imagine the feeling. And so as a result, we're trying to change that in Castleman disease. And we've been pretty effective. I mentioned earlier that our approach for Castleman's was to build this community of physicians, researchers, and patients. We actually turn to patients for all of our research ideas, along with physicians and researchers. I shouldn't say we just go to patients, but we ask 3 simple questions. The first one goes to every patient in our community. What research questions are important to you? And we ask physicians, what research questions, if answered, would be important to your patients? So this is fundamentally, what do we focus our research on? We focus our research on what's important to patients. So patients actually enter in their ideas, their questions, their comments. We most recently, we actually are in the middle of a crowdsourcing effort right now. Last time we did it, we got 64 ideas. This time we have over 150 different research questions. And so we get the research questions from patients, we get research questions from physicians and researchers, then we turn it into what research studies can be done to answer those questions. And then finally, what researchers are currently doing that work, whether they're Castleman's researchers or not. So this is a way to really integrate patients into the process, not because it's just the right thing to do, but because it actually is the best thing to do for science and for medicine, is to make sure that we're really doing research in the areas that we need to do research in. And I guess the last thing I would say is that our patient community certainly does feel empowered knowing that in Castleman disease in particular, patients have really been a part of driving this process forward. They're in scientific advisory board meetings, we're in clinical meetings, we're establishing diagnostic guidelines and treatment guidelines.
Maria says, this is terrific and inspiring. How can there be a more efficient pipeline to identify drugs for rare disease?
So the number one challenge is that there are very few incentives in place, right, Mikkael? I know you would agree that when drugs get approved for one thing, there often are few incentives to figure out what are other diseases could it be helpful in, particularly when that drug's generic. So if it's generic and there's no one really making any money off of it any longer, the incentives aren't there. So I think that first off, we have to address incentives, and I think we need to potentially have legislation so that way, if you do find a new use for an old drug, that you actually could have some sort of financial incentive in place. That's hard to do. The generic manufacturers don't like those ideas. And so that's a hard thing to make happen. The second is that I think letting people know that this is a thing, and that's one of the reasons why I wanted to write Chasing My Cure, is to highlight this example that I'm alive today because of this concept. I think encouraging the fact that this can happen and that there are things out there to be found, I think is really important for physicians and researchers and the general public to be aware of. And hopefully that will encourage a number of advocacy organizations, these disease organizations, to actually encourage funding into this whole concept of drug repurposing. What else would you add that could be helpful for encouraging this?
Yeah, it's a great question. So I actually served for 5 years on the Oncologic Drugs Advisory Committee at the FDA, or ODAC,
Wow.
and I chaired it for 2. So that's the committee where, if you're reading in the newspaper that a committee at the FDA voted to approve this drug, that was our committee for cancer.
Wow.
And one of the incentives that's there is for what's referred to as quote unquote orphan diseases, not my term, where a drug company gets additional marketing exclusivity for their drug if they identify it for either an orphan disease or for kids. Believe it or not. It's really hard to enroll kids into trials also because of all the ethical stuff around that. So there's a little bit of an incentive. One of the greatest challenges, though, in the United States is that the FDA only considers the science. So when we were in these committees, Rick Pazder, who heads up the cancer branch of FDA, would very clearly say, we are not considering economics at these meetings. We're not considering drug costs or the impact of drug costs. So that's handled really mainly by CMS. That's the major arm of government, the Medicare, that determines that. So I think, in addition to what you said, David, which I think is spot on about increasing incentives, at some point we have to bring the economics of this and marry it to the science of this in making decisions. And that may sound crazy, that may sound very logical. That's actually how the European Union does it. So they consider those things at the same time.
Yeah, and I think economically, I mean, it's great when cheap drugs like sirolimus are used for Castleman disease. The alternative, these are really expensive IV infusion drugs, and so how do we make it so that drugs like sirolimus, that we figure out when they can be used, when the incentives aren't there? Work needs to be done, but I'm actually really excited about this Cure Drug Repurposing Collaboratory that I mentioned earlier, and we've got a great team assembled. And actually, I'd love for you to be a part of it, obviously, given your background.
So Sandra is asking, how did your studies at the Wharton Business School tie to your cause journey? Maybe there's some connection there too.
Yeah, so in a few ways. I mean, one and the most just clear way was that while I was in business school, I would be listening to a lecture from a business school professor about, let's say, Shake Shack. They're talking about some ideas that the Shake Shack owners had for how they were thinking about picking a certain type of meat. And while I'm hearing that, the whole time I was in the middle of this Castleman's mode. So it was, well, how could that affect, what we're doing with Castleman disease? And, a minute later, I'm emailing 15 different doctors and volunteers and team members. We're going to do this differently. And of course, they don't know that it's inspired by Shake Shack, but it was this incredible opportunity where I was in the middle of this mode of trying to solve problems problems that were obviously very medically focused, but having the opportunity to, like, in one ear, listen to these incredible case studies, principles about business and problem solving and strategy. And then at the same time, the whole time I was in class, all I was thinking about is, how does this have anything to do with Castleman disease? And as soon as I would figure out a way it could be useful for Castleman's, I was running with that idea for Castleman's. So it was this incredible opportunity to just really put theory into practice. That was the most immediate way. But when I think a little bit more long term, I think that there were a lot of concepts around the way that business occurs and the way, and kind of in a quote, efficient market, how that works. And then when I compared that to the way that research is done, which is a quite inefficient process, there were some really clear opportunities to say, well, maybe we should do things a little bit more like this and a little bit less like that. And I see you're nodding. I'm sure you feel the same way.
It's just, part of it also is that what's motivating drug development? It's business, it's economics. Yep. So it was actually incredibly insightful on your part to chase an MBA as you're chasing your cure, because that's what's going to drive discovery, is to understand the business and how businesses operate and how to, bring things across the finish line. It's absolutely how to do it.
I agree.
So I would like to ask you, and I'm sure it's in the book, but do you have a personal philosophy? What is it that makes a person like you so magical and so resilient? Because I think that a lot of that goes into whether or not you do find the cure, whether or not you do recover. And I'm just interested in knowing more about what you think along those lines.
Well, thank you. It's very nice of you to say that. I think for me, the reason I'm sitting here today, I could probably boil it down to a few things. So the first is that I had the most incredible mother in the world. She was such a strong person, so resilient herself. And I knew that in her health, but particularly in watching her battle with brain cancer, it was just incredible to watch how she dealt with challenges. So many of the things like laughter during tough times, or figuring out ways to cope with the pain, these were things I learned from my mom, which helped me so much during my challenges. So I think one, learning from her was just essential for me, being able to have almost a roadmap for how to get through the tough times. I think second, and undoubtedly, was the support I had around me from my dad, my sisters, and from Caitlin. They were the only thing more relentless than Castleman disease, I think, is my family and their support for me. They just wouldn't leave my side, and that physical presence and the fact that when I was with them, it made me think about the future and envision what a future could look like. That pushed me to want to keep fighting. And then I think the third piece of it is that I was able to assemble an incredible team of people. As I said before, it's called Chasing My Cure, but that really was I think, a mistake in how we named it, because it really has been an incredible team of people, mentors like Arthur Rubenstein, colleagues of mine who were doing their MD, PhD while I was in medical school, who just gave maybe hundreds, maybe even thousands of hours of their time towards this cause. And so I think I boil it down to, I was fortunate to be born the son of Anne-Marie Fagenbaum. I'm fortunate to have this incredible supportive group of people around me. And I was very fortunate to be able to assemble a team of people who could be a part of Chasing My Cure.
Well, I want to thank you for writing the book, bringing the book into the world. I want to thank everyone who's watching from everywhere this evening for being a part of our event. Thank you for joining us in our little virtual bookshop. I hope that we will see you soon in person. That is my hope. I want to remind everyone watching that you can order a copy of the book by just pressing the green button on the bottom of the screen. Thank you to the University of Miami Department of Medicine. I know a lot of folks already have received a copy of the book through their sponsorship. So we thank you for that as well. And thank you, Dr. Sekeres. It's a pleasure to meet you. Welcome to Miami. And I hope that we will see you, as I said, in person at some point. And I hope that you will stay safe, stay well, and thank you for your work, both of you.
Thank you so much,
everyone.
Okay, good night.